everybody, this is Dr. Nigro here with another Chem Calculations video. This one is going to focus on mole conversions. There's going to be 4 videos in this series. This first one will be the introduction, and we'll look at the conversion between moles and grams. All right, before we get started, we need to remember how to actually conduct a conversion problem. Remember, conversions require unit equalities, and those unit equalities let us set up ratios which become our conversion factors. All right, so when we want to go from moles to grams or moles to particles, we need conversion factors to make that happen. All right, so we're going to start by looking at that conversion from moles to particles. All right, now particles is a very general term here. Particles can be anything. All right, we have learned in class that 1 mole of any substance contains 6.02 times 10 to the 23rd particles. All right, this 6.02 times 10 to the 23rd is also known as Avogadro's number. All right, and it stands for anything. As we learned, a dozen we know is 12 items. A ream is 500 items. A mole just happens to be 6.02 times 10 to the 23rd items. All right, now it doesn't make much sense to talk about things like basketballs or soccer balls or baseballs in terms of a mole because that's a lot of items. But items that are really small, such as atoms, molecules, protons, neutrons, electrons, all right, it's good to be able to put them into a group that actually is something visible to the naked eye. All right, so Avogadro's number is really large, but it makes sense because we're dealing with stuff that is really, really small. All right, so that unit equality is going to allow us to set up conversion factors where particles can be on the bottom and moles on the top of the conversion factor or vice versa. The conversion factor we use depends on what we're trying to cancel. All right, now if we wanted to look instead at the conversion between moles and mass, all right, and we use grams, all right, we're not going to be able to use Avogadro's number for that. Instead, we say that 1 mole of any substance is equal to its molar mass, and that unit will be grams. All right, the molar mass of a substance, if we think about Avogadro's number, we have 6.02 particles within that mole, and each of those individual particles has a certain amount of mass. So if we take the mass of all of the particles and add them up, we get the molar mass for that set. All right, now the molar mass of elements and compounds can be found using the periodic table. All right, so for example, if we just have an element, let's say we have oxygen, I can go to the periodic table and I see underneath the symbol for oxygen 16.00. So if we're talking molar mass, that means grams, and that will be the mass of 1 mole of oxygen atoms. All right, we can also put oxygen into a compound such as water, all right? And we can determine the molar mass of a compound by adding up the molar masses of the different elements. So in this case, we have 2 hydrogens. We take the molar mass of those 2 hydrogens and add them to oxygen, and we find that the molar mass of water is 18.02 grams for every 1 mole of that substance. All right, so we can use the molar mass as a unit equality as well, and that gives us 2 conversion factors where grams can be on the top or the bottom, depending again on what we're trying to cancel. All right, so when we're working problems, you're going to need to know these 2 unit equalities, okay? The first set of problems that we're going to be looking at are going to be converting between grams and moles, or mass and moles. All right, so for problem number 1, it asks, what is the mass of 3.21 moles of copper? All right, so I have 3.21 moles of copper, and we're asked for the mass. All right, when I'm first starting out teaching and working these mole conversion problems, I like to actually have a little plan. So I write a little map off to the side on my paper where I start with what I've been given, 3.21 moles of copper, and then I list what I'm trying to find, which in this case is grams. And then I ask myself, what is the conversion between moles and grams? Well, as we mentioned above, I'm going to need the molar mass of copper. All right, so I go look on the periodic table, and based on the periodic table, 1 mole of copper has a molar mass of 63.55 grams. So that's going to be my unit equality that I'll use for my conversion factor. All right, to set the problem up, as we always do, we start with what we've been given, 3.21 moles of copper. And our conversion factor is going to go next. We've got moles of copper in the top, so we want to use that in the bottom. So 1 mole of Cu goes on the bottom, 63.55 grams is going to go up top. We check our canceling. The moles are going to cancel. We're going to be left with grams of copper, which is what the problem asks us to find. So now it's just calculator work. So we're going to take 3.21 times 63.55, and we're going to find that 3.21 moles of copper has a mass of 204 grams. All right, now I don't know if you've noticed, but I'm using my units, I'm including my units rather, in all of my calculations, and I've got the symbol for the element. All right, that's pretty important, particularly when we move into stoichiometry, because we'll be moving from compound to compound, and you need to keep track. So your units really should also include the chemical entity. Okay? All right, so let's move down to number 2. Number 2 says how many moles of MgOH2 have a mass of 245.1 grams. All right, so we've been given mass and we're asked for moles. All right, so again, with a quick plan, 245.1 grams of magnesium hydroxide, and we're asked to determine the number of moles of that magnesium hydroxide. All right, again, we're going from grams to moles, so that means I'm going to need the molar mass of that magnesium hydroxide. So somewhere to the side, you're going to need to calculate that molar mass. All right, so the molar mass of magnesium hydroxide, I go to the periodic table, I take magnesium, and then I add 2 oxygens and 2 hydrogens. And I find that the molar mass of magnesium hydroxide is 58.35. Your unit here is going to be grams per mole. All right, so our unit equality would be 1 mole of that magnesium hydroxide has a mass of 58.35 grams. All right, so with the unit equality set, we can go over to our problem. We start with what we've been given, 245.1 grams of that magnesium hydroxide. I'm abbreviating that with the MH. All right, we look, our unit here is grams, so I need the grams in the bottom. So 58.35 grams is going to go underneath, and 1 mole will go up top. I check for canceling. The grams are going to cancel. I'll be left with moles. So I get my calculator and I divide 245.1 with that 58.35, and I find that this mass of magnesium hydroxide is equal to 4.20 moles of that MgOH2. All right. So you can see here 2 different ways, starting from grams and going to moles, or starting from moles and going to grams. Both of them use the same conversion factor in that they're both molar mass conversion factors, but one is flipped with grams on top and the other has grams on the bottom, depending on what we are trying to cancel. All right. So the next video is going to look at particles to moles, and then a later video will go moles all the way, or sorry, grams all the way to particles. Okay.